We're down to the community discussion, how to do USNG right. And to the degree we bleed later into the day, we can go as late as 3:28 before I turn into a pumpkin. Um, okay. And to get the show rolling, I got to see where we don't want to do that. So in coordination, Randy, myself, and Al made kind of a plan where each of us would talk about something for 10 minutes, and things have kind of mutated around. And the way we've decided to approach this is Randy will talk basics of USNG first, to the degree of kind of setting the stage for a topic that he will call, the is USNG a point solution, or is it a square solution, or something along those lines, which I'll let Randy come forward and discuss in what he's got set up for first the general idea of what he has, and then maybe more in depth on that issue. And with that, I'll shut up and follow Randy with three examples of the way USNG could be implemented more appropriately. Randy, you have the floor.
You will have to allow sharing, Steve.
Yep, here we go. You're all set up.
All right. You can see my screen.
We can.
Okay. Um, so my name's Randy Knippel. One topic that I like to bring to the floor, at least for discussion, is the U.S. whether the U.S. national grid is points or polygons. And this is a conversation that comes up on a regular basis. The U.S. national grid is a grid referencing system, a location referencing system. It covers the entire U.S. Technically, it covers the entire world. It's based on UTM coordinates, and it's really just a convenient notation for those coordinates. U.S. national grid is synonymous with the military grid referencing system, or MGRS. There are some variations in the actual notations or formats, but effectively the USNG and the MGRS are the same. If we look at the Federal Geographic Data Committee standard, um, you can find that with a Google search. It says that a point position is that the U.S. national grid is a point position where the number of digits will depend on the precision desired. It shows some examples there in the standard. And so therefore, if we look at a full U.S. national grid location reference, it's 15 characters. The last 10 characters are the X and Y positions. And the number of digits in that X and Y represents the precision. So if it's the full designation, it's representing 1 meter precision. If it's 8 digits, it's 10 meters, 6 digits, 100 meters, 4 digits, 1,000 meters, and so on. We can also truncate on the left side if our entire area of operation is contained within 15T VK Victor Kilo. We don't need to say that over and over again. Once that is clearly understood by everybody that's participating, we can simply refer to the grid numbers themselves. And so right away, you can start to see some efficiencies that come into play through this truncation and precision. So if we look at practical applications of the precision and truncation, I didn't do the truncation here, but here if you see if we're using the full precision to 1 meter, you can think of that as representing the space that it's occupied by an individual person, for example. If it's 10 meters, that's all we really need to represent the location of a large vehicle or a small home. If we're using 6 digits, that's 100 meters of precision. That's all we need if we're locating to a large city lot, a football field, something like that. If we're using 4 digits, it's 1,000 meters, and we can think of that in terms of a city block or a neighborhood. 2 digits is 10,000 meters, might be an entire city, and so on. So it just gives you a way of visualizing the kind of uses for the precision. We only need to represent the precision that's necessary, or perhaps we're representing the precision that we have available in our GPS device or that we're able to measure on a map. So fundamentally, the U.S. National Grid is all about using maps and representing locations on maps and teaching first responders and the general public how to measure on maps and how to find locations on maps, how to relay locations that they see on a map using the grid itself and measuring on those maps. But we can also use the grid itself as a convenient way of creating a map series. So in this case, I'm showing examples of a map series at 1 to 6,000 scale, 1 inch equals 500 feet, on 8.5 by 11 map sheets, where each map represents a 1 kilometer square. And so we can use the 1 kilometer grid squares as the naming convention for this map series. I'm sorry, I need to cough. Pardon me, I couldn't find my mute. We always teach people to read right then up. So if we're on a map and we get a location of 7556, we teach them to read right to 75 up to 56, and that is the lower left corner of a 1,000 meter square. The grid reference, grid location always references the lower left corner of a grid square of a particular precision represented by the number of digits. So we need to remember that. If you're using full precision, it's a 1 meter square, where the UTM coordinates are the lower left corner of that square. If we then look at on a map like this in 1 to 24,000 scale, we look at that grid 7456. That's the lower left corner of that square. That can then relate to a map at 8.5 by 11 that represents that entire 1,000 meter square, even intervals, with additional detail. And then further, if we add another digit, that represents the grid square on that map. And this would be a 100 meter square in this case. And so we're representing 100 meters of precision on this map. And then if we want to go further, we can estimate within that square, adding another digit, right 3 up 8. And we're now representing a 10 meter square, even though we're showing it on the map as a point. For all practical purposes on this map, it is a point, but it still represents a 10 meter square, 10 meters of precision, where those coordinates represent the lower left corner. So why is this important? Well, if you're in a situation like this, as Stephen Talbot were discussing, we've lost all visual cues in the field. You don't have street signs, you don't have addresses, can't tell where buildings start and stop. It's just one continuous debris field. The U.S. National Grid gives us the ability, using GPS, to be able to navigate in this area and then use the information about that location in conjunction with maps to be able to do things like coordinate a search and rescue effort, so that we know when we're in a specific area which grid square represents that, and then perhaps be able to relate that to a map and identify areas that have been cleared or areas that may contain something else that's important. So what we're really doing is teaching people how to use these maps without having to understand all of the intricacies of GPS and map projections and things like that. And then there are apps that can be used in conjunction with this too. This is showing the USNGI.org app, where it's giving you your location, but it's also representing the precision of the GPS device, or the GPS on this device at this time. So the red digits represent that we don't have a high degree of confidence in that location. So really, we know that we are in 834533, which should be a 100 meter square. We've got some digits down here to 10 meters, but we can't be completely confident that we're precisely within that 10 meters of precision. Here's an example of a search and rescue. This was an actual situation in Dakota County where they had to do a search. They had to search through this entire park that was heavily vegetated with dense undergrowth, including buckthorn. If you're not familiar with that, it's very difficult to move through these areas. But what they were able to do is, with a search team of 10 people, they put a GPS receiver on either end of a line. It proceeded to go from either the south or the north within a grid square they could follow their GPS, and when that the third and sixth digit changed, they knew that they were leaving that particular 100-meter square. So it allowed them to systematically go through this area, and relay their results back to a command center by simply saying something like grid 880621 clear, and move on to the next one, and so on. It allowed them to be very systematic as they went through this, and were finally successful in their operation. When we're making maps, though, we need to remember that we're talking about labeling UTM coordinates. And so we need to make sure that we're labeling the lines for practical uses of the grid so that people can measure using those lines. We give them a location. They're going to be able to follow those lines up to the intersection of those lines, and then measure from that with additional digits. This is showing a grid overlay widget that Esri provides with their application development toolkit that will represent the grid at varying degrees of precision as you zoom in and out on the map. So it's a really nice little tool. And what I'd like to do really quickly here, if I can find it, is bring that up. This is showing an example with the National Alliance of Public Safety GIS Professionals Situational Awareness Viewer. They are using that grid overlay widget. And you can bring it up here. You can adjust a variety of things, but I just want to show the interactive nature of this. As I zoom in, it's going to start to show. Here's showing the 10,000 meter squares. Here it's showing the 1,000 meter squares, and you see it's labeling the grid lines. And as you zoom in, it's adding additional digits, adding more grid lines and additional digits. You'll see down in the lower left corner, it's also showing my U.S. National Grid location. As I zoom in, it continues to refine that. So now it's showing 3 digits in X and Y, and so on. It'll get all the way down to 10 digits and so on. So it's a really nice little utility. There is an issue that needs to be addressed with this, with the USNG implementation working group. As I said, this is a widget that was created and made available through the current Esri toolkit, but it has not been migrated as of yet to their next generation toolkit. And NAPSG is lobbying for that, and we need to engage and do our best to make sure that that does move forward, because it's very important for our purposes. The USGS provides a map series covering the entire U.S. called the U.S. Topo Series. It's a 7.5 by 7.5 minute quadrangle at 1 to 24,000 scale, where 1 inch equals 2,000 feet. According to national mapping standards, the map should be accurate to a 30th of an inch at map scale, which translates to about 20 meters. So that means when we're measuring on these maps with a Romer scale or something like that, the best we can do, according to national mapping standards, is measure to an accuracy of 20 meters. So we should not be trying to represent a location measuring on these maps to a precision greater than that. And so that's really how that all comes into play with precision. And then fundamentally, what people say, why not use lat long? And the issue here is we don't really know how big a degree is. At the equator, the degree of latitude and longitude are approximately 69 miles. But as you move towards the North or South Pole, the lines of longitude converge, and degrees of longitude get smaller. So that means that distance calculations are difficult. And the point here is, when we're using U.S. National Grid locations and specifying the precision, it's very clear, just based on the number of digits, what your precision is. When you're talking about latitude, longitude, how many digits of degrees or minutes do you need to use to convey the location? And you simply can't do it. So in summary, U.S. National Grid is a point referencing system of varying degrees of precision. Therefore, U.S. National Grid effectively represents the lower left corner, lower left coordinates of a square indicated by that precision. It's important to remember that. The number of digits represents the precision, not a discrete point location at those coordinates. Unless you fill it out the rest of the way with zeros, you're not specifying that level of precision. So in conclusion, for practical purposes, the USNG is both a point and an area referencing system. And while we want to make sure that we're teaching it as a point referencing system and how things are measured, effectively, it is always an area of representing the level of precision. So I'll leave it at that.
So, Randy, you have a Talbot has been kind enough to be patient, has had his hand raised for a period of time, and I believe he has an input for you. So, Talbot has the floor. Go for it.
I just want to is when y'all going to talk about populating grid squares with attribute values and popping things over to like a raster and modeling, or have y'all talked about that at all? Even it sounded
That's really what
Dennis
George
might have.
and others are engaged in.
Who's is that? Randy? Okay, let me jump in here real quick. Talbot, we haven't wandered into that kind of level of specificity. And I would encourage you, if that's a topic that you want to take on, we would be more than happy to host you on a presentation along those lines. So,
Sure. And could Randy pop his presentation back up for a second and just go back a couple of slides?
do you want to go back to the Esri slide?
No, the search slide.
Oh, okay. One sec. Did I stop? I think I stopped sharing.
Yeah.
You seeing it?
Yeah. Roll back a couple slides, please. There you go. So something I just want to plant a seed, and I'll follow with Steve and do a presentation about it some other time. You can imagine trying to conduct a search in this vegetation. And as a search manager, one of the pieces of information that we're trying to figure out is what they call probability of detection. And so you can imagine that if I took a beach ball and set it in the middle of a Home Depot parking lot at 10 o'clock on a Sunday night, one person's going to find it, right? But if I put that beach ball down on Saturday morning at 9 a.m., it's going to take a whole lot more people, right? And so the same goes with vegetation thickness. And what we can start to do is pull values and use them to populate or color USNG squares. And Randy had kind of showed this in one slide before, but I don't think he touched on it. One more back. You have the tornado severity damage. There it is, right? And so you're now, instead of weighting it or coloring it as we searched it or we didn't, it can be it's horrible damage or it's not. And you can now take one last step and imagine each of those grid squares is really a pixel. So you could convert it to raster and you can start doing raster math with it, or you can leave it in vector format and do some vector modeling, because what the grid does as an area framework is it provides a common analytic mask as well.
And not only that, Talbot, but it's also very easy to aggregate by simply dropping a digit. You can aggregate from 100 meters to 1,000 meters to the 10,000 meters by just dropping.
Oh yeah, and aggregate points within the polygon, all kinds of great stuff. So you know, y'all, somebody can grab it and run there, or I'll do a presentation later. But I just thought it kind of worth mentioning.
Well, the points in the polygons as well. You don't even have to do spatial analysis. If you have U.S. National Grid point locations or locations at precision of 10 meters or 1 meter, whatever, it's very easy to count them to 100 meter square or 1,000 meter square by simply taking the first 2 digits or 3 digits of each X and Y. You don't even have to have a spatial analysis to do that. It's simple logic.
Isn't that kind of what Al did in that article he wrote on the fires with the damage assessments in the individual lots. I'm not sure.
I think,
I point out one more thing. There's a little subtle detail in this. I had given training to this team on the U.S. National Grid, and they had the GPS receivers. They had one member of their team had the ability to create quick and dirty maps like this that they could use to help coordinate their effort. And when they got called out to do this search effort, their first reaction was, come on, we're just going to get out there and do what we do, and we'll get it done. They got out there and they got so tangled up and lost in the underbrush. They stopped their operation, went back to their command center or their operations center, and said, all right, let's do it the right way. And they broke out the GPS, they broke out the map, went back out and did it. And they were 100% behind this whole concept after that experience.
okay. Thank you very much, both Randy and Talbot. I'm going to grab the screen back here and let's see, I think. Well, let's go have some fun with what I've dug up. Okay, here we go. All right, so at the top of the screen there, this is no kidding, a real world example. Joe example, GIS analyst, any state, county, city, whatever. And he's got the world knowing where he is by using decimal lat long, as you can see right there. And if you're running out to 6 places, that comes out to less than 1 meter, 16 digits. And so I started needling him about doing that. So he dropped US National Grid on there. So now we got 10-meter accuracy, not the equivalent. But do we really want to use decimal degrees in the first place? And this is kind of a runaway thing in the GIS community to start with. It's a notation expressing latitude, longitude. It's machine to machine. It's designed for use within geographic information systems to start with. And as if you read the discussion even a little bit further, it's an alternative. So let's drop down and look at 1 meter precision and change it to degrees, minutes, seconds, and if you typed it into the FCC conversion site, you also end up with digital seconds, which takes it out to 18 digits. And as you heard from Randy, you can get rid of 15T and Victor Kilo, and 1 meter precision now is, at 10 digits on US National Grid. Now, are you confused yet? Because I'm going to confuse you even more. Now we jump into this thing that I think Talbot had a heavy hand in making sure was in existence. The NASARC manuals, both for critical incident and or for land-based SAR, have something to say about how you should be dealing with latitude, longitude in the response community in the first place, and specific to if you got to use it, how you should format it. Now they're saying degrees, minutes, decimal minutes. I never heard of that before. What the heck is that all about? As you can see, it lays out 2 primary ways of relating location, US National Grid and latitude, longitude in the format that's shown there. Well, where'd this degrees, minutes, decimal minutes thing come from? Here's a real flight plan by yours truly that I had buried somewhere in my Northwest Airline paperwork, and it shows you what latitude, longitude looks like when it's used in the cockpit. What's the reason it's that way? Is because the inertial measurement units, or the IMUs, or inertial navigation systems, are designed specifically to take digits in that format. I guess we got a lot of chat going on. Let me see what's going on here. Looks to me like we're good. I'm going to keep pressing on. So that's the bottom line for you to understand why it is that if you look at the search and rescue manuals, why they have wandered in to using latitude, longitude in this format because this is what works in the real world, not in machine stuff or not in the FCC conversion to something that isn't used in the real world. Okay, pressing on past this, there's also this reality that Randy already beat up. Your precision with latitude, longitude changes because where you are relative to your longitude around the world will drive how precise it is. And that's not a good way to be doing business. Whereas latitude, longitude, or U.S. National Grid is is always denoted as to its level of precision. Okay, now we jump over to somebody that's selling a product out there that has.
Before you leave that, Steve, this is
Yep,
Jules again, real quick.
yep,
Uh, the Unfortunately, in that SAR document, it reflects I'd say the cultural differences that we always have to deal with. The people that fly airplanes over big distances, I call them the round earth navigators. They use lat long in its form like that. But you'll notice that all of the Landsar response shows the U.S. National Grid, and that's because in local areas the U.S. National Grid is uniform and more useful. That's why there's a military grid reference system that's used for tactical activities as opposed to lat long, which is used for driving ships and airplanes over distances. And
right,
so, for just this reason, we had to get a chairman of the Joint Chiefs of Staff instruction that specifically told the military that when you transition from aviation support to combat operations to ground-based combat operations, you will transition from lat long to MGRS. So same idea applies that for local areas, cities, counties, even bigger, the U.S. National Grid or military grid reference system is best. And then when you're going over long distances, lat long is probably more appropriate. So that's where that came from.
yep, understood. Thank you, Jules. Appreciate the comment. Okay, here we go. This is a product out there that is actually being sold universally to state governments. And if you open it up when a location for a 911 call comes in, it transitions if you will, you see it there as the second item down here in lat long. Well, there it is, machine to machine talking for latitude, longitude. What's the first thing that comes out of the system? What three words? Okay, great. I wonder how much money was paid to make that happen. Degrees, minutes, seconds. Well, we just talked about why that doesn't work in the real world. MGRS, they had some silly thing in there that went beyond uh, 10 digits. I don't remember how many were there, but it was clearly well past what the display on standard of MGRS would look like. And then last but not least, what you'll find in there is Google Plus codes. Is US National Grid mentioned here anywhere? Well, you're supposed to know that it's the same thing as MGRS, blah, 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 blah. Well, okay, what works best? This is just the reminder grid of what USNG is capable of doing versus what these other approaches to your location hold the potential to do. And clearly, if you're looking to have in place the best solution inside your software, it certainly looks to me like USNG is the winner. And then there's this thing. You mean there's more standards than NASARC? Well, we've listed on the website all the various places in which U.S. National Grid is either mandated or provided as a reference for how business should be done. And as you can tell, once again, did we implement a GIS product without really understanding what the user community needs were and what the standards were. And then we wander into, well, if you start rendering that kind of level of confusion into the community, what's the end result look like? Well, once again, up on the USNGI website, you can find the various events that have taken place. We've just put some of them up there of what's taking place about lost on the way to response. Then we move into this. I don't think Al is able to tune in, so I'll do my best to try to relate Al's ideas. He focuses in on the whole thing about many of the implementations try to usurp what Randy was talking about, that they show the centroid location as being the indicator for the entire grid square itself. So, in this instance, he's asking us, hey, it's great to have a map, but how about putting some notation on it? Many of them don't. And so when you see a USNG product that's been implemented without the coordinate capability around the edge of it, not a very good way to go. Next, we come up to what I was talking about with the centroid or the corner that Randy beat up pretty extensively. And then finally, more of a breakout with what shows here for a product that's called GIS Surfer that Joseph Elfelt out in Washington has put together. And you can see that it breaks out both where your cursor is at up here and where the center of the particular grid square that you're looking at, how it would actually map out versus what may be shown as the centroid. So there is a difference. And again, Randy beat that up pretty good. So with that, we get down to the point where the floor is open for the last 15 minutes or so, to the degree that there are additional comments, we want to talk about things, whatever. Let's see what's in the chat. Has anybody got something here that they want to pass along? I'm not seeing anything special.
Steve, I threw out a link to that NAPSIG situational awareness app.
Okay.
It's pretty cool. There's a lot of stuff that they put in there. I was not aware. I only recently became aware of that, but I think there's definitely something on our to-do list for the IWG is connecting with the NAPSIG U.S. National Grid proponents and coordinating our efforts.
Okay, thank you.
A question for Jules, if he's still on the call.
Yes.
The cost, I used to see the argument with respect to how you were storing and transmitting the data, saying that USNG is going to take on one of the forms I've dropped in the window: communication cartographic, standard, cartographic standard, and whatnot. But and not care how 911 transferred the data around and actually made the point appear on the screen. And it was like, as long as you label the point or have a grid on top of the map, then it becomes the communication or cartographic standard. But I started back of the envelope pencil whipping this and started moving into your universe a bit more, in that, Esri used to, and all JS vendors used to convert all the spherical coordinates to integers and store them that way, right? And then, and so there was a limitation on both precision in the geodatabases we used and on the actual size of the databases. But that switched over because folks started storing this crap as floats. And I found behind the scenes that Esri is padding my coordinates and crap with a pile of zeros, which end up taking up space on my drive. So all of a sudden I did start caring about, okay, look at how many millions of points of data I have times the number of digits that are really reflective of the precision of measure, what is the real cost between these two systems for data storage format? And it's non-trivial when you start getting this to scale at like the federal enterprise side. And I'd be real curious if there's an argument to be made around that now. Because we've gotten to these levels of precision and measure where lots of zeros do matter. Did that make any sense?
Well, just in terms of processing and storage economy, I don't really know how to address that though. Yeah, everywhere you look in government, it seems like, or in these uh, GIS activities, Esri is deeply embedded.
Yeah,
And
and everything's driven on a spherical coordinate model. Nothing is being stored in a planar system. It's getting converted.
that's just a current we have to swim against. I mean, it's
Right,
the
but
it,
so if FGDC is concerned about cost, well, here's a real cost now.
well,
Yeah, anyways,
yeah,
sidebar for another day.
I'm not in a position to be able to address that at the moment, though. Though we might bring that to up to Tom Terry or one of the other folks who are more engaged with them on a regular basis. Tom hasn't been
Yeah,
involved in our discussions for a while, but he'd be a good one to talk to about that, I think.
yeah, yeah. I'll nudge him. We'll probably talk today again.
Can I suggest a different solution?
Yeah,
As Randy mentioned, as we wandered through hit this afternoon, um, we are intent on beginning to write letters pointing out deficiencies at organizations. And one of them that we were going to look at was the labeling issue at Esri, as well as the issues that Randy brought up this afternoon about labeling going away in one of the tool sets, basically writing a letter in support of NAPSIC's position. It would seem to me that Talbot, one of the approaches, just like what we're going to do with the census effort, would be if you'd be interested in formulating a letter like that, we could put it forward to the appropriate body, whether it's the National Geospatial Advisory Council or the FGDC, but at least it would carry more weight than just one person doing it or Jules trying to knock on some back doors. At least I would like to believe so.
yeah. Okay, let's kick that around.
Okay, thank you. All right, any more thoughts, ideas, comments from the floor?
As that shown, I just want to piggyback on one of the portions from earlier about, emergency response people, particularly fire coming into an area they're not familiar with. I do work some wildland fire with DNR forestry yet here as a weekends and stuff. And I'm not familiar with Hubbard County yet. And so I can see where the USNG would work a whole lot better for getting me to a site where I'm supposed to get to in a reasonable amount of time without wasting a lot of time on the phone trying to get directions, having to try to keep up with other trucks, just different things like that. So yeah, I can see um, that point of view very clearly.
Thank you, Edward, for that comment. Talbot was long a firefighter down in several places, but principally in his current residents of Cleveland and Alstud, who unfortunately is unable to tune in. Both of them have always been adamant about the use in the fire service of U.S. National Grid. So hopefully, as we continue to build efforts, the word's going to continue to spread and mutate out. I think we've got about 3 to 4 more minutes if we'd like to use it. Otherwise, we can call it a wrap, but it's not to discourage anybody from making comments. But I just want to make sure the floor is open and we have awareness of where we are. The floor is getting ready to close. Going once, going twice, gone.